just drew. What do you notice?
The ones that are linear and have a very directly are just a straight line.
They are a straight line. You're absolutely correct. Look at it again. Is there anything else that you notice about those graphs? These two, 1 and 3, are a straight line. Do you notice anything else about their graphs that you can say, hey, this is the same on both of these? Do you notice anything else?
1 and 3 are proportional.
They are proportional. I agree. Yes, 1 and 3 are proportional. What else do you notice? Just looking at the picture. What else do you notice about the picture? Does everybody have it graphed? What else do you notice about the pictures? Michaela, what do you notice about the pictures? They both. Lines 1 and lines 2 have a y-intercept of 0. Those lines both go through the origin at 0, 0. Do you see that? That tells you that they are a direct variation. It will tell you that every single time you ever see a graph where it goes through 0, 0. They will be proportional. They will be a direct variation every single time. Okay? Lines cross at 0, 0 on the axis. And I know I'm writing that crooked, but you get my message, right? Those lines will always cross at the axis. Now you said you have a question.
Wait, so is the meaning of a linear graph that it's just a straight line?
It is a straight line, yes.
It says 1847. Oh, you want these to be 6 times 2, 4 times 2, and that. But 4 times, it doesn't. Skip the line.
It's because they didn't show it all to you, but if you take and you find the slope, what is 12 minus 6? Because slope is change in y over the change in x, right? And what is 8 minus 4? So your slope there is 6 over, okay, which is the same thing as, you agree? So what that's saying is that 1.5 is multiplied by every one of those. The fact that they skipped from 12 to 18 doesn't really matter, okay? The fact that their slope is a consistent change, rate of change. That's what makes that proportional, okay? Hang on a second, please. Yes? I'm trying to think of what they're doing today. 8th grade. Yes. Okay. Bye-bye. Okay. So did I answer your question? Okay. Any questions so far? Okay, well let's look at my definition. Because if you look at our goal today, you will use a formal definition of direct variation. Here's my definition. Two quantities, x and y, show direct variation when y is equal to kx, where k is a number and it cannot be 0. It can't be a 0. The number k is called the constant of proportionality. One of the things that I hate about this book is that it's showing it as y equals kx, But that is the same thing. K and M are the same thing. K and M are still talking about the slope. They're the same thing. The reason they're calling it K is because, yes, it's talking about the slope, but it wants you to understand that is a constant proportionality, a constant rate of change. That's why they called it K. They don't just want you to see it as slope. They want you to understand it's the rate of change. Okay? They want you to see it as the rate of change, because if you understand rate of change, then all the rest of this just is like gravy. As long as you understand the rate of change. Okay? So they're calling it K. The graph of y equals kx is a line with a slope of k that passes through the origin, like you identified in the two that we said were direct variation. They vary directly. Okay? Making sense so far? Okay? Let's see. Let's see what we can do with it. Here's what we're going to do today. Tell whether x and y show direct variation. Well, in order to tell that, I have to know that the rate of change is constant. Okay? So if I look at going from x to y, I've got to find out what rate of change. I got to find out that k. Do you agree? And k is the change in y over the change in the x. Okay. Same stuff we've been dealing with. So if I have 0 minus negative 2 over 2 minus 1. I'm using these two right here. Okay? Well, what's 0 minus negative 2? What's 0 minus negative 2? What's it going to be? 0 minus negative 2. What's it going to be? 2.
Add opposite 2.
Add opposite. And what is 2 minus 1?
1.
2 minus 1 is 1. So the rate of change there is 2. Do you agree?
Yep.
Okay, now the question is that constant? Is it the same throughout the table? Well, there's only one way to find out, isn't there? What is 2 minus 0?
2.
What is 2 minus 1? Wait a minute. What is 3 minus 2? Is that rate of change the same as this rate of change?
Mm-hmm.
So is the constant rate of change the same? So is it direct variation? Should I check something else
No.
to make sure?
No.
If I did, well, what's 4 minus 2?
2.
What's 4 minus 3?
1.
Is the rate of change going to be the same?
Yes.
Yes. So in A, yes, it would be the same thing as y equals, what was k?
2.
2x, wouldn't it? Is
Yeah.
that what's happening?
Mm-hmm.
4 times 2 would give me 8. That doesn't look right, does it? Because I'm looking to see whether I'm coming back to this, right? My slope is a 2, but is my rate of change, is it coming back the same? Is it working? I got a slope. It's not the same thing though, is it? Not in this case. How do I go from 1 to negative 2? How do I go from 1 to negative, because this isn't going to work for me. What's 1 to negative 2?
Add negative 3. Add negative 3.
What was that?
Add negative 3.
Okay. So I'm going to erase some of this. 1 minus plus -3 equals -2, okay? If the rate of change is the same, 2 plus -3, does it equal 0? Doesn't, does it?
No.
Is the rate of change exactly the same?
No.
So how have I gone from 2 to 0? Oh, that's 2 plus -2, do you agree?
Yeah.
3 plus -1 equals
-2.
2, do you agree with that? Is the change consistent?
Yes.
No, the change keeps changing, doesn't it? So is this direct variation? Is A direct variation? Is A direct variation?
No.
No, it's not. It's not. And I can check it by doing what? What'd you say? Can you graph that?
Yeah.
Graph it. Graph A. Yeah, you're gonna be doing lots of graphs. It's okay. Graph paper's cheap. Get it graphed. Just graph A. I'm gonna start off with just that one. Because then we're gonna talk about something else.
Yeah, she's gonna mind blow us.
No.
And
Gonna make it easy though.
why can't you just do that right now? It would help us.
It's really not the best graph paper. Might try that. Make it a whole lot easier. Did the graph of A go through at the origin?
No.
No. So this is not DV. We're not DV. Okay. Could I have looked at the table and saw that
No. Yeah.
really quickly and easily? If I understand that the direct variation will always go through 0, 0. Look right here. Is that an ordered pair?
No. Yeah.
X and Y, right?
Yeah.
So the ordered pair here is 2, 0, right?
Yeah.
The ordered pair here is 1, -2. Do you agree?
Yeah.
This is 3, 2. This is 4, 4. Do I have a 0, 0 ordered pair?
No.
No. And if I don't have it, I don't have direct variation. Can't happen. Look at this one.
Yeah.
Is B going to be a direct variation? What do you predict?
Yes.
Yes, graph it. Be safe. Make sure.
Yeah.
Yeah. Do you know what the pattern is?
Yeah.
Do you know what the pattern is on that one? You might try a ruler instead of the calculator as your straight edge. And you might even try a pencil. You're really having a good time doing your own thing today, buddy. Here. Miss Alice. But when you graph it, you can find it.
Is it from 19 yesterday?
If it's, good point, good point. Okay, Miss Alice said, when we were back here on number 3, do you see the ordered pair 0, 0? No. So just the fact that it doesn't exist doesn't mean it's not direct variation.
Yeah.
The difference in number 3 and this one is, I do see the ordered pair 2, 0. That in itself tells me I won't have a 0, 0. Okay? Does that make sense? Also, when I look at this one, 0, if x is 0, y is 0. If x is 2, y is 2. If x is 4, y is 4. If x is 6, y is 6. If x is 7, y is 7. What's happening?
It's a constant.
Y equals 1x.
Okay.
So this is, that would be my formula. So the slope is 1 and it's constant. Good. The constant proportionality is the multiplication of 1. Okay? Here, I didn't have a constant proportionality, because I couldn't find that constant proportionality in that rate of change. Couldn't do it. Okay, there's a lot of different ways of doing it. Okay? Let's check this one out. Tell whether x and y show direct variation and explain your answer. I got a formula. Yeah. How am I going to know by looking at that formula, or can I tell by looking at a formula, if I'm going to have direct variation or not? How would I know for sure? What do you think, Mr. Tanner?
What, no,
You say no. Why not?
cause there's a plus 1 in it, and should be multiplication if it's gonna be direct. And it wouldn't be a 0, 0.
Okay.
Probably wrong, but,
I wouldn't say you're wrong. Here's the way you're going to know, though. In order to know, solve the equation for y. In other words, y's got to be by itself if I solve for it. Do you agree?
Yeah.
How do I get y in A by itself? What do I need to move out of there?
A 1.
The 1. And how am I going to do that, Jillian? Add a negative 1. Great job. Y equals 2x plus negative 1. Okay? Remember when we go back up to the beginning? What was our formula here? Y equals 6x. The second one, did we do the, y equals 1 5/10 x. When we go over to here, y equals 1x. When we get to here, y equals 2x plus 1. Is it direct variation?
No.
No. Because of that right there. So this is not. formula for what, for direct variation is y equals something times x. Plus or minus nothing else. You're looking for y equals kx. That's constant proportionality. Y equals kx. No plus, no minus attached to it. That's it. That's like saying, I don't even know how to put, I'm not even going there. Forget that one. Okay, look at B. How do I solve for y? How do I get it by itself? How do I get by itself? Times it by the reciprocal or times 2. Good job. Do you agree with him? Can I say 2 over 1 times 1/2 y equals 2 over 1 times x? Is that a true statement? Sure it is, because aren't these two going to cancel each other out, leaving one y behind, and y equals what? So what's the constant proportionality in B? 2. Okay? So this is direct variation. Muddy? Is it muddy in your brain right now?
No.
Some of you can say yes, okay? And I'm all right with that. All right, let's go a little bit further. This is what we're doing. Just look at the table.
Yeah.
Is it gonna be, is number 1 direct variation or not?
No.
I want you to look at it, keep your mouths off. Tell me thumbs up, yes, thumbs down, no. Put them right here. That way I know if you know what you're doing. Thumbs up it is, thumbs down it is not. This is what I'm seeing. Now, my question is, why not? Why not? Come on.
Well, because you have to have a 0, 0, 1
Yeah, I can't have a 0, -2. It's not going to cross the y-axis. And I could graph it to test it. Or I can look at what's going on. But no, it is not. You're absolutely correct. The fact that I see the ordered pair 0, -2 tells me no way, no how. Can't be. Okay? What about number 2? You have a question?
If it would it count if it was like a straight line along the 0 line?
Do what, son?
A straight line along the 0 line, because then you'd have 0, -2, and 0, 0.
But it doesn't.
It doesn't. because
So it doesn't work.
one.
Okay? All right. What about number 2? You gonna graph it? You could. You're gonna see if there's a constant proportionality? How do I go from 1 to 4? Times 4? That's what I heard. If that's true, then that means I should be able to take the next number and multiply it by 4. Can I?
Yeah.
Is 2 times 4 gonna give me 8?
Yeah.
Is 4 times 4 gonna give me 16?
Yeah.
Can I write the equation?
Yeah.
What's it gonna be? What's my equation on this one? What's it gonna be? Very good. Y equals 4x. So is that direct variation?
Yes.
Sure is. This is a yes. DB, direct var. What about number 3? Thumbs up, it is. Thumbs down, it is not. Thumbs up, it is. Thumbs down, it is not. This is a no. It is not. Why not? Oh, wait,
It's a yes.
it's a yes. Sorry. This is yes.
This is equal to
Why? Why? Because we know what? What do we know, Savannah? Has that 0, 0. Could I come up with that if I want to? How do I go from -2 to 4?
add 6.
She says multiply by -2. What's -1 times -2? -1 times -2 is? -1 times -2 is? 0 times -2 is? 1? 1 times -2 is? Talk to me. You're right. Is this times -2 going to give me that? Oops, guess what we just found?
We just got
We
mind
just
blown.
found a flaw,
I
didn't
told
we?
you we were gonna get mind blown.
Graph it. It's called a parabola. Because this is not going to be linear.
It's the work
Is
graph.
the constant it worked all the way up to here, didn't it? Did the constant proportionality of the -2 still work here? No. So, guess what?
We just got mind blown. Olivia just blew our mind.
I just blew the theory out.
This is string theory on steroids.
So should we use the theory? In theory, should we use the 0, 0 as something that gives us the
No,
answer?
no. You just
Not
tricked us.
alone.
You
Not
tricked
alone.
us. She tricked us.
I'm confused now. You check that first.
Okay, there we go. I like that.
I think I'm getting it, and then I.
Okay, hang tight. Listen to what Zane said. Zane, say it again.
You check if it has 0, 0 first, then you go and do the other stuff. Because if it doesn't have 0, 0 at the beginning, and then you do all the other stuff, and then you figure out, oh, I could just check it with 0, 0. That'd be real easy.
If it has 0 with a different number, then you automatically know.
Oh, yeah. That one's true. If it has 0 with a different number, you automatically know it's not.
So check for that.
But, so you can check for that one. But, when you see the 0, 0, you can't guarantee until you've tested it.
Okay.
So you have to test for that constant proportionality. You've got a good idea here, but when we started going down that times -2 didn't line up. It didn't line up, so it doesn't work. Okay? Let me see. I'm going to stop there. Let me look at, you know what? Because I think you probably have just enough to be Goldilocks and be successful and not be all messed up. Let's look. Let me look. Oh, yes. Oh, yes. Open up. Go to page 110.
No.
Stop arguing. Stop whining.
Okay.
Turn to page 110 in the math journal. There's 10 problems there. Maybe you'll get another 3 or 4. Come on.
Come on. Cheetos.
Okay.
Come on, Cheetos.
Now then. And honestly, what we did here was exactly what you're being asked to do here. Okay? Look at numbers 1 through 6. Let's look at 1, 2, and 3. Look at those first. It says, tell whether x and y show direct variation. Explain your reasoning, and if they do, you have to find the k. So let's look at them. We got 3 different answers. Number 1, we're going to do number 1 together. Gee, that makes you have less, doesn't it?
Yeah.
Okay, number 1. Does are x and y showing direct variation?
Yes.
Yes or no? Are they showing direct variation? Showdown. Yes is thumbs up, no is thumbs down. Yes, they do. Thumbs up. I agree. Now then, explain your reasoning. How do you know that they show direct variation? How do you know it?
Because you get from 1 to 2, you do times 2, and if you multiply 3 by 2 is 6.
She says, because you're multiplying by 2. Is she correct?
You multiply by 3.
Oh, I see what you're doing. You're multiplying all the x's by, you're multiplying the x's by 2. Is that what you said, babe?
Then you also multiply 3. You would also multiply the y by 2, so to get the answer in it. Like, yeah. So it's 1/3, like 1 over 3 is equivalent to 2 over 6.
Oh, she says, looking at equivalent fractions, is 1/3, 2 6, 3 9s, and 4 12s all equivalent? They are. What about if you said 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 4 times 3 is, what's the constant proportionality? Y equals 3x, or the constant proportionality is 3. The constant proportionality is 3. Here's what we knew. Everything here was multiplied by 4. Y equals 4x. That's proof that they are direct variation. And to answer the question, the third part was, what is K? K equals 4. This would be my 3 answers, wouldn't it? Yes, it is. The proof is y equals 4x, and the constant proportionality is 4. In what we just did, yes, it is. The proof is y equals 3x, because 3 times x, and the constant proportionality is 3. That's my 3 answers.
So we don't have to explain because
That explains
y
it.
equals 3x is our explanation.
Exactly. Y equals 3x explains it.
Oh, so
Okay.
we don't have to.
Okay? Y equals 3, and you only, it says, tell whether they show direct and then explain, and if so, then you got to find the K. Okay? So if they're not direct variation, are you going to have a K? No, because it doesn't exist. Okay? That's 1, 2, and 3. Now, 4, 5, and 6. What do you have to do with 4, 5, and 6? Well, let's look at this. What if I took this number 4? What do I have to do to find out? I have to get what alone?
Y.
This is making sure you have just enough. I'm going to divide by, what's the opposite of multiplication? Y equals negative, y equals 3 divided by x. Is that constant proportionality?
No.
Not that way. Ooh, I don't like that. Are they doing that to you? They are going to do it to you.
Bad math textbook. Math workbook.
Hang on a minute. I know they're doing it to you, though. I want to make sure.
Yeah, number 6.
On 5.
And I'm going to make sure that you see it.
Is it eating us? Don't let it eat us.
Yep, I was right. So at this point, is this one going to have a constant proportionality? Not the way it is. This one is a no. No. Okay, look at number 5 here. I'm just gonna make sure we're gonna do the rest of these so that you know you got what you need. What's the opposite? Or if I've got 1/3 times y, how do I get rid of the 1/3? How do I get rid of it, Aaron? Multiply everything by 3. So is 3x equal to y? Is that a constant proportionality? Yes. So this one is a yes. There's my y. And what's the k? K equals 3 on this one. Good. See it? Easy. Do you see it?
Yeah.
Sorry about that. I didn't mean to scare the bejesus out of you. What about number 6?
No?
Tanner says no. I agree with him because if I solve for y, and that's what? There's my proof. No, it is not constant proportionality. There is my proof to back it up. I've explained why it is not. Okay? Let's see, that gets 1 through 6. 7, 8, and 9, the variables x and y, they're saying they vary directly. Use the values to find the constant proportionality and write an equation that relates. Well, that's pretty simple. How do I go from x is 2 and y equal? It's telling you we know they're constant proportionality, right? So if x is 2 and y equals 8,
We just have to write.
what did I multiply x by to get y? Y equals 4x. Isn't that what it is? What's the matter, babe?
We don't.
It hurts head.
Okay, here, look here. This is what I want. Do you agree? If they tell me if y is 8, I could substitute the 8. Do you agree?
Yes.
And they tell me the x is 2, I can substitute it in. What does k have to be?
4. Oh, yeah.
Okay, yeah. I get it. I get it. We divide 8 by 2.
Okay.
You divide them.
Actually, I just did 7.
Yeah.
I was like, yeah, I knew I did it. Gee, that's 2 that you don't have to do.
Writing
Yeah.
and so we just follow the formula.
Yeah, I'm glad I'm doing that. Okay, does that help you? Okay. Now then, you got to do 8 and 9. Number 10. Huh? What's it tell you to do with number 10? Yeah, I know it is. What's it tell you to do with number 10? Graph it. That's pretty simple. So finish. We're doing math journal 110 and textbook. What's that page? Because I mean I've already done a couple of those, right? Textbook 203, 30 to 34. If you need to take a restroom break, go now. And then we'll line up and go to lunch.